Hi, this is Professor Stugard, and in this video we're going to talk about the different kinds of problems that machines can solve. So in this video we're just going to talk briefly about how machine learning is a little bit different than your traditional type of programming, and then we're going to talk about the three main types of problems that we solve with machine learning. So one of the big differences is that in traditional computer programming, we write a program that's going to ask for certain inputs or data. And again, a program that does a very specific thing. Then the computer is going to give you an output based upon that. Well, in machine learning, it's a little bit different. We give the computer our data, and we know what our desired output is going to be, and then the computer is going to generate the parameters of whichever program or algorithm we choose so that it can be used to actually get the desired outcome that we want for our given data set. Which means that each time we do a machine learning project, the computer is basically creating this algorithm, creating this method for learning based upon the data that we give it. If we give it a completely different set of data, we're going to get a completely different program or algorithm out that's been tuned. Now, with that in mind, let's talk about the three main problems that we use machine learning to try and solve. And that's regression, classification, and clustering. Now, there's obviously other types of problems, and even in each of these three very broad categories, there's lots of different distinctions and different algorithms that we can use for these different types of problems. But this, again, is just a very general overview of the types of problems that we're going to be learning how to solve. So the first is regression. And this is where we try to make predictions based upon the estimates between variables. All right. So we have to look for some sort of relationship or some correlation between variables that we can then estimate and then use that estimation to make predictions or to try to forecast the future. Now, the simplest is linear regression. And we've probably all seen linear regression at some point, that y equals mx plus b, where we use the least mean squares to try to come up with the best possible linear model based upon a data set with only two variables. But again, it all kind of follows that same process where we input some values x to predict some value y. And so the example I have here is we could plug in the square footage of a house as our number x, and that's going to estimate the price of the house y. Now, there's going to be other variables, including neighborhood and things like that. And again, in general, we might have more than just one explanatory and one response variable, but the main idea is the same. We hope to capture the relationship between these variables with some sort of equation, whether it's a line or a polynomial or something along those lines, so that lets us make predictions where I can plug in any new value and have an hopefully somewhat accurate prediction about what my output is going to be, what my response variable is going to be. The next type of machine learning problem is classification. And this is where we just identify, okay, my data point, well, it should be in either category 1 or category 2. Or if we have a multi-class classification, maybe category 3 and 4 and 5 or so on. Again, we'll start with the simplest ones where we either classify something as belonging or not belonging, a two-class classification or a binomial classification. And so, again, an example of this would be when we use a machine learning algorithm to evaluate an X-ray, it's going to classify whether a tumor is cancerous or not. And so we can see here in my little example that, again, just based upon two simple variables here, we have patient's age and the tumor size. All right, is it going to be cancerous or not? And we can see that they definitely seem to be a way that we can classify it. If I draw this line here, all right, everything is on one side of the line and everything else is on the other side, and we've classified it two different ways. One of the things that we're going to be looking at, however, is, well, sure, I can draw that line there, but I kind of did that arbitrarily. Is there a best line? Because if I get new data points, well, is that line going to accurately describe them? I drew that line there, but I could have easily drawn my line here instead. Well, which one of those lines is the best line? All right, and that's a problem that we're going to investigate further on as we continue learning about machine learning. Now, the last type that we're going to talk about is clustering. And clustering is where we try to group together similar data points into these collections or these groups or these clusters that allow us to really discover how things are naturally organized. And so this can be really hard for humans, especially with large data sets. And so in this example, it's not even that large of a data set. We have under 400 points of data, which is nothing compared to the huge data sets that are used in real life. But it still can be hard for us to look at this and say, okay, well, what would be my natural clusters? Well, I run it through my machine learning algorithm, and now I can cluster it in 3 different clusters. And hopefully we see with the red, the blue, and the green, okay, this kind of makes sense now. There's much more of a pattern to these points. All right. So with machine learning, again, the goal of the project is going to help you choose whether you're doing a regression problem, a classification problem, or a clustering problem. And then even once we determine what's the general problem we're trying to solve, there are multiple algorithms we can use for each one. Now, sometimes it might be obvious, sometimes not. Sometimes it'll seem obvious, but we still guess the wrong one. You're going to have to go back and try a bunch of different algorithms. You might have to try different methods. Because again, you might not have asked the question that you really think you were trying to answer. So much of this is just playing around and learning as you go and developing intuition for data and how to learn from it or how to tell the computer to learn from it. What kind of patterns we can tell the computer to try and draw from that. And so we're going to be talking more about, again, each of these algorithms, which requires a basis in mathematics. And so we're going to have to learn or go over a little bit more about statistics and different types of mathematics that we're going to be using here with machine learning. All right, so at the end of this video, there's only really one question that hopefully we can all answer. First of all, what are those 3 main types of problems that machine learning can solve? And then try to think of your own examples. Think of data sets and answers we might want to pull out of those data sets and try to think of an example for each one of those major classifications, or not classifications, each one of those major problem types. All right. Hopefully we learned something, and as always, take care of yourselves.